Hello everyone, Mr. Minix, my name, math is my game. I hope the recording turns out okay. Been having trouble with the sound, and I can't believe I've used this same battery in this microphone now for probably about 6 hours. They say you get it about 8 hours, so we'll see how it goes. All right, so today I'm joined with my Algebra 2 class. It's the day before homecoming. I don't understand how that works, but anyway. We're going to be looking at 3 forms of quadratic functions, one of which we've already seen. So we'll just review the first one. The first one is called vertex form. We've seen it. We should know it, but just a nice recap of it. It says y, or f of x, is equal to a times the quantity x minus h the quantity squared plus k. Now, a couple things about each of the variables. A and h and k, those are going to be replaced with numbers at some point. Those get replaced with numbers. So a, h, and k must be real numbers. They must be real numbers. You don't have to make your r fancy like that if you don't want to, but I like to. They must be real numbers. And there's one other thing that we said, a restriction, if you would. Something that a is not allowed to equal. Does anybody remember? Yeah, a is not allowed to equal 0. With a not equal to 0. So the cool thing is we've seen this. We should kind of have an idea how this works, what it's good for, what we would use it for. Can somebody tell me an advantage of having a quadratic function given to us in vertex form? Yeah. If you understand it, yeah, you should already know the vertex and the axis of symmetry. And what else did you say? I missed the last part. And the a value, right? Yeah, the a value is pretty clear. So you should be able to graph something given in this form pretty quickly, right? Does that make sense? Cool. So the deal is we should know the vertex. Remember, the x-coordinate of the vertex is the h, and it's the opposite of what you might expect. And the a value is pretty clear. And so if we have something in that form, we ought to be able to graph it pretty quick. So on the upcoming quiz over this material next week or maybe the week after, I might ask you to compare and contrast all 3 forms of quadratic functions. Wouldn't that be a good one? I know some of you don't particularly care for the essay questions. So let's just look at example 1. We'll go ahead and try to graph something like this. Y equals negative the quantity x plus 2 the quantity squared minus 3. So on yesterday's quiz, you did this. So this shouldn't be that bad to do. What are the coordinates of the vertex? Yeah. -2, -3. Good. So our vertex is at -2, -3. The vertex is at -2, -3. And I know it seems like, oh my gosh, is this all we're going to do this year? No, believe me, we're going to do a lot more. So the vertex is at -2, -3. So -2, -3. There's my vertex. -2, -3. Now my a value, it's not real clear what it is, but if you understand those implicit things in mathematics, who can tell me what my a value is? Yeah. -1, good. Yeah, the a value is actually -1. So from the vertex then, we said we're going to go over 1 and up or down whatever a is. Well, a is -1, so over 1 and down 1. And then since the a value is 1 but it's flipped over, this function with respect to the vertex, it's going to look a lot like the parent function, just flipped over, right? So from there then, we could go ahead and go over 2 and down 1, 2, 3, 4. And I don't think I'm going to have any more room to go any further than that. Okay. So that's pretty cool. That's pretty cool. So there's this other form that's sometimes nice and sometimes not nice. So we'll look at this other form. This other form is the one we're going to look at in the next section, and it's called standard form. I should note that some pre-calculus books actually call this general form, I think. They actually don't call it standard form, they call it general form. But standard form of a quadratic says y equals ax squared, well actually y equals f of x, which equals ax squared, plus bx plus c. So just like before, we're going to say for all real numbers, for any real number a, b, and c, for any real number a, b, and c, and again, a is not allowed to equal 0. So in this particular form, a is not allowed to equal 0. And I think we've mentioned why that's the case before. If a happens to equal 0, what would happen here is this whole first term would go away, and we'd just be left with a line, wouldn't we? So that's why a is not allowed to equal 0, because we'd just have a line left. Okay. So the interesting thing about graphing functions that are in this form, do we know what the a value is? Yeah, we know what the a value is. Now, there is something else that we might know. We know that the a value kind of tells us it's not exactly the slope, but we know it tells us if the graph opens up or down. There's one more thing in here, and I don't know if anybody recalls from Algebra 1 what that might tell us. So, what do we got? Whoa! Can I shout you out? Shout out to Chad Ramsell. He said it's the y-intercept. The y-intercept is the value of y whenever x is 0, right? So that's going to be the y-intercept. So the deal is the graph will pass through the point 0, comma c, because that's our y-intercept. Nice. Now, aside from knowing the y-intercept, we really don't know much else other than whether the graph's going to open up or down. So I guess what the point I'm trying to make here is standard form doesn't show us the vertex. And if you had to find the vertex given a function in standard form, you know how time consuming it's going to be? It's going to take about 3 minutes to find the vertex. Maybe not. After you do a couple, it won't take that long. Are there any questions so far? So what I'd like to do in the next example, I don't want to try to find something's vertex yet in standard form. What I'd like to do is try to take the example from example 1 and put it into standard form so we can compare. Does that make sense? Good. So what I'd like to do is I would like to take and write y equals negative the group of x plus, was it plus 2, the quantity squared, and then minus 3? Cool. Let's write that in standard form. Now, I always give a shout out to this one person, this one teacher in the high school in the social studies department who would know how to do this. I could call him on the phone. Yeah, I could call him on the phone, and he would know how to do this. Of course, we would need to use PEMDAS. And in the parentheses, there was really nothing to do, so the next thing we would need to do is the exponent. We'd need to handle the exponent. So that exponent of 2 here, you know what that means to do? I think some people do know what it means to do, and other people want to take shortcuts. Now, I've told you about shortcuts. What do we got to do? To handle it, to simplify, to... Yeah, we have to multiply the quantity x plus 2 by itself. Okay, we have to multiply the quantity x plus 2 by itself. Excellent, excellent, excellent. I'm glad you got that. Half the people in the world don't know that. What I'm trying to say is people want to make up their own rules about exponents, and people want to say, well, x plus 2, the quantity squared, is x squared plus 4. I've got news for you. No, it's not. No, it's not. I don't understand why this happens, but students who take pre-calculus, students who take calculus, students who take abstract, people go on and they make this mistake. They make this mistake all the time. I don't understand why. Just to confirm that it's not equal to the same thing. Watch what happens here. Watch what happens when we multiply this. So we're going to get, when we FOIL, we multiply the first terms, right? So we're going to get x squared. We multiply the outer terms. Whoop, I said the outer terms, and I didn't multiply the outer terms. So the outer terms is going to give me plus 2x. The inner terms is also going to give me plus 2x. And the last terms product is going to give me plus 4. So that ends up equaling x squared plus 4x plus 4. Okay, so the x squared plus 4, the people who think that that's true, well, that might be good enough for Meatloaf. You know, Meatloaf said 2 out of 3 ain't bad. Unfortunately, Meatloaf passed away a couple days ago. Did you guys? Or no, I take that back. Scratch that from the record. Meatloaf didn't pass away. He turned 71 or 70. It was his birthday. But anyway, got to clear that record. All right. So we still got this negative hanging out front. We got the minus 3 at the end. We got the negative hanging out front. We got the minus 3 at the end. So we did the parentheses. We did the exponents. Now what should we do? Yeah. Distribute that negative 1, right? We got to distribute that negative 1. That's a negative 1 that needs distributed to all 3 of those terms. That's the multiplying part of this. So that's going to be negative x squared minus 4x minus 4. And then there's still that minus 3 at the end. So we're almost done. We're almost done. Finally, we would just add or subtract. In other words, combine our like terms. So our answer here is going to be y equals negative x squared minus 4x minus 7. Negative x squared minus 4x minus 7. What do we think of that? That's kind of a little bit of work, isn't it? It's not a matter of snapping your fingers and having it. It took 1, 2, 3, 4 or 5 steps. To quote George W. Bush, it's hard work. He used to say that back in the day. Bless you. So, what's our C value in this? If we take a look down here, what's our C value in this? I'm trying to make a star around it. What's our C value? Yeah. Our C value is the negative 7. Now, earlier, we said that that's the y-intercept, right? So let's go back and look and see what the graph had for a y-intercept. It was negative 7, wasn't it? That's pretty cool. That's really cool. Well, in about 3 weeks' time, 2 weeks' time, you know what we're going to be doing? We're going to be doing that skill that bridges the gap from junior varsity math to varsity math. It starts with an F. Not foiling, factoring. We're going to be factoring. So there is a form of quadratic function. So we've seen vertex form. We've seen standard form. There is a form of quadratic functions called factored form. There is another form, and this is the third of the 3. This is called factored form. Other textbooks don't call it factored form. They call it intercept. They call it intercept form. Okay? So what it looks like is this. Y equals f of x equals a. Oh my gosh, this a shows up everywhere, doesn't it? And it does the same thing. So understanding what a is a real big deal. Times the group of x take away p times the group x take away q. And again, for any real number a, p, q, with a not equal to 0. You mean we're going to have to factor? Yeah, that's coming up in about a week, or about 2 weeks. Oh, I remember factoring. So fun. So I did mention that some textbooks call this intercept form. So I wonder what P and Q are. P and Q are the, anybody want to take a shot at it? Know what they are? Somebody said it? X and Y intercepts? Not quite, but you're close. It's one or the other. The X. P and Q are the x-intercepts. P and Q are the x-intercepts. So in other words, the graph will go through the point P0, and the graph will go through the point Q0. In the same way that H is counterintuitive, P and Q are also counterintuitive. In the same way that H is counterintuitive, P and Q are also counterintuitive. So what I'd like to do is I'd like to start off with something relatively simple that I believe we should be able to factor. Just because you've probably seen it and it's one of those special cases. And I just want to kind of compare and contrast factored form to vertex form. And we won't be doing too much more today, so we're about to wrap this pretty soon. We ready? Good. So here we go. What are we on? Example 3. Example 3. Change to factored form after graphing. After graphing. What do you mean change to factored form after graphing? You'll see. You'll see. Y equals x squared minus 4. Y equals x squared minus 4. So if we look at this function the way it's given to us, which form is it given to us in? Standard form? Vertex form? It's definitely not factored form because I'm kind of telling you have to change it to factored form. So is it in standard form or vertex form? Yeah. You say vertex form? Does anybody else say standard form? You're both right. You're both right. What the heck do you mean, Mr. Minnick? How could this be in both forms? Well, let's think about what standard form looks like. Standard form is y equals ax squared plus bx plus c. Right? That's standard form. Well, what's our b value here? In standard form, what's our b value? Isn't it 0? Okay. In vertex form, if we think about vertex form is y equals a times x minus h squared plus k. So we can kind of tell what our a is. I think we could tell what our k is, but what's our h? Our h is 0, right? So this is a very unique instance. I don't know if you remember the names of them. Sometimes that's not so relevant, but so a couple things to take home from this. Because of the standard form, I guess we would know that the graph's going to go through the point 0, negative 4, right? And because of the vertex form, we know that the vertex is actually 0, negative 4. Does that always happen? No, very, very rarely. This is just a rare bird. So my vertex here is at 0, negative 4. So we said the a value is 1, so what are we going to do? We're going to go up 1 and over 1, right? Or over 1 and up 1. So we're going to go over 1 and up 1. Got it. And then what? Over 2 and up how far? Over 2 and up 4. Which is going to put us there. Oh! And then from the vertex we could go over 3 and up 9. So that's going to put me up here and up here. So I'm going to go ahead and try to sketch this graph as best as I can. Go ahead and sketch this graph. And what I'd love to do if I can, if my smartboard cooperates, is I'd like to zoom in on that area. I want to go ahead and send that to the current page. Do you see what my x-intercepts are? Negative 2 and positive 2, right? So if we had to put this thing into intercept form, in intercept form, we know our a value is 1. And the graph's gonna the function's gonna be x minus p. Well, p's is negative 2 here, right? So what's x minus 2 gonna be? Yeah. Positive 2. So that's gonna be x plus 2. And then when we look over here, that q value is 2. So it's x minus q. So over here is gonna be x minus 2. So to answer this question, there's Whoop, I guess I need to bring that box to the front. Order, bring to the front. Right there, that's vertex form. That's vertex form. I'm sorry, not vertex form. My bad, that's a neck. That's intercept or factored form. Do you kind of understand a little bit what factored form is going to give you? Okay. We're going to look at one more. I know we said we're about to wrap this up. We're going to look at one more, and then that's it for the day, I promise. Because it's pep rally day, isn't it? And it's the end of a short week, but it's been the longest short week of my life. You guys don't have school tomorrow, I do. All right, last one of the day. Here we go. Last one. Let's go ahead and try to graph. Let's go ahead and try to graph y equals negative 1/2 times the group x plus 4 times the group x minus 2. And I know what you might be saying to yourself. Self, I have no idea where the vertex is, so I don't know where to start. And that's probably true. You don't know where the vertex is, so you might not know where to start. But you know some things about these functions, don't you? You know symmetry. And what else do we know? The coordinates of the x-intercepts, what are they? Well, remember they're counterintuitive. So -4 and 2. All right. So we know that the graph's going to go through those points, right? And we know because of the a value that this thing is going to do what? Open downward, right? So we know if we sketch this thing, it's probably going to do something like that. We don't know how steep. Well, we kind of know how steep it is. Wouldn't it be nice if we knew where the vertex was? Could we tell? Relative to the x-intercepts, where do you suppose the axis of symmetry is going to be? Relative to the, somebody said it, what did you say? In between these two? Well, how far in between those? Dead smack in the middle, right? You guys just came up with the formula to find the x-coordinate of the vertex. So how do we do that? We just kind of average those 2 points, right? So what we could say is h is the average of p and q. So that'd be -4 plus 2 over 2, which would be -2 over 2, or -1. So our axis of symmetry is x equals -1. Now there's one more thing that if we did, we could figure this out without touching a graphing calculator. Now I showed you all 3 forms for a reason. What form, can you read my mind, what form am I going to change it into now? So that I can get one more point. Might not be the vertex, but I could get one more point. And with symmetry, should help me figure this thing out. Not vertex form. Standard form, right? If I put this thing in standard form, I'll know my I'll know my y-intercept. So I'm going to go ahead and FOIL this out. What's that going to be? That's going to be x squared minus 2x plus 4x minus 8. So that's going to be x squared plus 2x minus 8. And then I got this negative a half that's multiplying all that. So this is going to be -1/2 x squared. Now what's half of 2? 1, so that's going to be minus x. And then half of 8 is 4, and that's going to be a plus 4, right? So my y-intercept is at plus 4. My y-intercept is plus 4. You see what I got going on here? I can use symmetry. Because if I compare like this point and this point, it looks like I went over 2 and up to 4. So the other, I guess by symmetry, I'm going to have this point here, right? Now, is anyone clever enough to realize relative to that, since that's 1 unit away from the x-coordinate of the vertex, where the vertex is going to be? Yeah. So where are you saying the vertex is going to be? -1 and what? Not 5. 4.5. We have a winner. It's 4.5, right? Because the A value is a half. Now, if you don't see that, don't sweat it. Not the end of the world, but the vertex would be, the vertex here would be -1, and then 4.5. Okay. So there is a reason that I showed you all 3 of these forms. They relate to one another. Factored form is good because it gives you x-intercepts. Standard form, honestly, the only thing standard form is good for is to give you the y-intercept quickly. And maybe if you're typing something in on a word processor, maybe it's going to be a little easier to type in. Vertex form, if you're graphing, vertex form is probably the most useful. Would you agree? Especially if you're identifying maxes and mins. So that's it. It's been real. It's been fun. The rest of the time is yours to, I don't mind if you talk quietly amongst yourselves. Just don't line up at the door. Thank you. Have a nice day.
Good.